We are now. Yeah, I think that would be nice. Yeah.
Yeah. I'm not quite famous enough yet that I need no introduction. So. Oh.
That was just joining us virtually.
Oh, fair enough. Hi, Alistair.
Okay. Well, welcome to our final talk of the day. I'm very pleased to introduce a stalwart of CamJam and Firewalls and indeed now Hacky Racers,
Yep.
Keegan Neave.
Thank you. Yeah, my name's Keegan Neave. I am a recovering roboticist. I think is probably the best way of putting it. I saw Short Circuit when I was young, and kind of got the bug for robots, and grew up in the 80s watching things like Transformers and the like, and it's just I need some of that in my life at some point. Everything I was doing at school and at college was with an aim to go to Reading University to study cybernetics. I got to that point, I had to resit my A-levels. Who resits their A-levels to get the grades to get in? Got there, and within the first week, the first lecture of engineering mathematics, and I said to him, the lecturer at the end, he's like, oh, you're talking about Fourier transforms and imaginary numbers and things like that. It's like, what's the application? How are they used? What are we going to use them for? And he said, oh, you'll find out in your third year. It's like, I won't be here. I have to do something to know how it works. And yeah, I dropped out. So I switched to computer science, got lucky because they discovered I was dyslexic 2 days before my appeal to switch degrees. So that helped. And yeah, through various jobs, became like a support engineer at Microsoft, supporting Visual Studio. So not like people calling and saying, why won't my start button work or whatever the problem is this week. Is I can't do this incredibly esoteric thing in C# using this API. Why not? And it's like, I have no idea. So yeah, constantly learning on the job. Everything was definitely learning as I went. So that experience, hellish though it was at the time, forcing me to learn different things quickly is a very, very big set of skills to have. Left there, accidentally became a visualization engineer, and was given the task of tracking every ship around the world in near real time using a constellation of 11 satellites, as you do. Using the Unity games engine because it wasn't difficult enough to start with. While I was working at that company, Firewalls happened. And for once, I actually found out about the deadline of the application before it had already passed. Like, I'd been following Firewalls for years, and I'd heard about it after the event had just finished or after the applications had just closed and so on and so forth. So this time, it was a couple of weeks before the application was due to close. I set myself the challenge of making a little robot, which was essentially this. And not this, because this is far tidier. I mean, the first one was literally gaffer taped together. My original blog was gaffer tape engineering, so I kind of staying true to form. But it's a remote control car, got from a local toy shop for 20 quid. I think that one had an Arduino on it with a couple of motor controllers, because that's what I had in a pile at the time. And I very roughly cobbled together a robot, and I thought, you know what, if I can do that in a couple of days, I can build a robot for Firewalls. So I applied with the incredibly silly idea, don't look so sad, come on. The silly idea of basically building Johnny 5 from Short Circuit, but 2 foot tall. Naivety doesn't quite cover it. I know my surname is Neave, but they may need a slight variation on the spelling for that one. But yeah, I applied, I got in, and the first robot was actually called McFeagle Prime. So this is old McFeagle Prime. He actually had the tracks, so whoever it was earlier who said, didn't Johnny 5 have tracks? It's like, yes, but they're a nightmare. So the original had the tracks on there, but for the final version, I just went with Mechan and wheels, because these are a lot more capable, but I'm getting slightly ahead of myself. As you can see there, this is the very naive version. This isn't even the one that made it into the first Firewalls I was in. Incidentally, after all those problems, missing the application in previous years and finding about the event after the thing happened, for the first one I got involved in, the first event was due to take place in person in Cambridge at the end of March 2019. A week beforehand, we went into a nationwide lockdown. So yeah, that event didn't happen. So this is, I think, is the state of the robot a few months after the thing should have actually happened. I think this was for this video was actually for the virtual version. It was kind of like a show and tell rather than actually doing the challenges. But yeah, so this one was using hobby grade motors, servos. You can see all the horrible wiring that just snaked up his arms because you had to have 3 wires per servo. It's all very naive, but it did work. And yeah, I was quite proud of that, to be honest. I carried on developing it just because I kind of got the bug by that point. And this is kind of the latest iteration. So this is NE5. Not that I'm like copying the name from its progenitor at all, but clearly it's the 5th robot that Neave Engineering made. Makes perfect sense. There's no trademark infringement at all. So he still has the LED rings around the eyes. Unfortunately, the code for it is in his other head. So Crichton would be proud of that one. But yeah, so this should get my brain in order really. So the original version had a stereo pie in his head, which gave access to the dual cameras. The idea there was you could do depth perception and lots of other things I never actually got around to getting working. And in his caboose, putting it politely, was a Pi Zero connected to the motor controller, which is a Red board by Red Robotics. Neil Lambeth made an absolutely brilliant bit of kit there, so yeah, well worth looking up. It's got 2 motor controllers on board and 12 outputs for servos. I actually ended up having an extender board, so I had 16 servos extra I could control for NE5 there, for McFeagle Prime even. And yeah, it worked. It was a good proof of concept. I learned an awful lot of lessons, I think is the diplomatic way of putting it. For example, there were that many wires going into the back of his head. If you asked the robot to look up too far, his head popped off. Because yeah, the strength of the wires was stronger than the 3D printed joint, so it just went. Thankfully, you could just kind of clip it back on. He also had a habit of, like one of the servos in his elbows had a habit of just coming out. So I ended up hot gluing the bejesus out of it, which turned out really handy at one point because the servo overheated. It got hot enough that the hot glue melted, and I found out that something was wrong because his arm fell off. So I went to pick it up. What was going on? It's like literally burnt my fingers. It's all right, power off. So yeah, very janky, very cobbled together, but very much labor of love for sure. Bit by bit over time, various bits have been improved. So the robot you see before you is, for the most part, the same as from Pi Wars 2020, I think it was. So, you know, the base box is the same. It's got 4 motors rather than the 2 that he had. Still got a Raspberry Pi in the caboose, but pretty much everything else has subtly changed. So this is essentially the same specs as for old McFeagle Prime, but I just changed a few words. So I will be open sourcing it hopefully in the next couple of months. I've basically been waiting for the point where all of the CAD and the code wasn't embarrassing, so that I could release it without just feeling ashamed. I probably should still be a little bit ashamed, but I've now passed caring. So yeah, this will be going out before too long with a full bill of materials. The biggest differences between the old one and the new one are the servos and the arms. So where before I was using hobby grade servos, which you can basically say, go to this position or spin this fast, which are great. You know, you can get very strong ones for like 50 quid, which used to be in these shoulder joints, and I think it could actually lift almost 0.5 kilogram at one point. He was cranky as all hell about it, but he could do it. But you couldn't get any position feedback. So when you switched the robot on and asked it to switch on, the servos would just go into their home position. So wherever they were, and even if you put them roughly in place, it would just go clunk as quick as it possibly can, which always made me jump. And typically, if something wasn't quite in the right place, it would just try and go through itself and rip off its own arm. The ripping off of its own arm is kind of a running theme. The elbow joint actually fell apart about half an hour ago as well, so it's a theme that continues. But the servos I'm now using are called Dynamixels. Other smart servos are available, no doubt, but these are the ones I've been using on a few other things. And one of the biggest benefits of these is that you can daisy chain them. So go on, hold out your arm. As you can see, so there's three wires that go in, which is power, ground, and data. And then it's got an input and an output, and you just daisy chain them all the way to the end. The wiring alone, it was worth it. But each of these actually has its own microcontroller, so you can interrogate each servo to find out what its position is, what its temperature is, what its current goal is, if it's like holding a position. Or you can even do things like, rather than move to this position, use this much current, which sounds like an odd one, but if you've got the gripper, what you can say is, I want you to use 0.05 amps. And it will basically carry on going until it's using that much power, at which point you know it's gripped something. So you can kind of use power usage as an analog for that. If you give it negative current, it'll go in the opposite direction. It's all a bit weird, but it makes sense in context. But yeah, so for being able to control these servos, it's a lot easier. And for things like the towns where Nature's Bounty, where you were grabbing the apples off the tree, I was basically bit by bit moving the old arms around, recording all of the values, and then playing them back. And I had a keyboard plugged into my controller where the top row of the keys were different positions for the top apples, the middle row for the middle, and the bottom was for the bottom. So it was all hard-coded, and it was a bit of a nightmare. But with these, you can basically literally go here, press a button, and it will record the positions of all of the of all the arms, and it just makes all of that much easier. The thing I was working on before this arm overheated and had to be all the servos sent to be replaced was actually implementing a kinematic model. So the kinematic model basically defines the position of this joint relative to everything else on the robot. So you can say, so it knows where this shoulder joint is, where its next joint is in relation to the previous one, and so on and so forth, chained all the way to the end. So rather than having to manually control each servo, which is what I was doing previously, you can just say, right, I want that bit to go to this X, Y, Z coordinate and to point in this direction or that direction and so on and so forth. So it'll just make everything a lot easier. So the controller, which I'm still damn proud of because look at it. So this is the control I've been developing over time. Again, this is the version 2. The first one was janky, and if you picked it up, it would basically almost cry at you because it was going to fall apart as soon as you looked at it. This one's far more sturdy. It's got a Raspberry Pi in there with the full touch screen. Also really chunky switches for the microphone there, because I love a good switch. The joysticks are also 3-axis. So when I mentioned before about controlling the arms, I'd literally, one axis would control a shoulder, as in the shoulder forward and backwards. The other one would control its rotation. And then because they're 3-axis, you can rotate it. That would actually control what I called the flappy axis, because I don't know what I'm doing. And it just, that's flapping. So that's the flappy axis, and that's what it's still called in the code. But then if you press and hold the button on the top, it then controls the elbow joint and the next wrist, and it's just a nightmare because it's like, right, move the arm up like that, then move it down like that, then you didn't quite get it, it's just a nightmare. So being able to just go forwards, sidewards, up and down, and have the kinematic model sort everything out is just going to be a dream. The other thing is in the head. So, and you're not going to be able to see this, so I'm not sure why I'm taking this off really, but for one thing, if you have something you need to access frequently, design magnets into your panels. It makes everything getting on and off so much easier. That's possibly the thing I'm most proud about this 3 years of development. But so rather than the stereo Pi, which is in the previous versions, I've gone for an Luxonis Oak FFC 3P camera module. I know that off the top of my head because I've had to Google how to use it countless times. But basically, this is a dedicated computer vision board that has 4 tera operations per second capability for image processing. So you can do things like combine the images from the left and the right cameras into a 3D point cloud so that you can then generate a 3D map of the world, which can be used for navigation and things like that. It also has a third camera in the middle, which is a high definition but has a narrow field of view, and that's for object recognition. So the side cameras can kind of look at literally the broader view, and then the middle one can kind of get focus in on whatever job you're doing. This then just connects over USB 2, and the great thing is that any of the code you write and run on the Raspberry Pi actually gets compiled and run on the board itself. So rather than having to get all of the data back to the Pi and then do all the processing there, it will do all the processing on the board and then just return the results you need. So that's a massive benefit on a kind of a resource-constrained device. Because let's face it, 35 odd quid for a Raspberry Pi, it's an excellent bit of kit. But if you need to do machine learning and things like that on high-definition video streams, probably shouldn't be using it. So those are the kind of the big changes there between old McFeagle Prime and NE5 Mark III. And yeah, so the kind of, to hook everything together, I'm using something called the Robot Operating System. And it's been around since 2007, I think, or something like that. It's used everywhere, including Mars. So yeah, it's got a bit of a record for doing crazy things, but it's basically, it's not an operating system, which is annoying me, and it annoys them because they know that they shouldn't have called it that. It's, I think, a programming meta framework. Basically, it's something that you can run in a bunch of places, and it does cool stuff. So it's got a communications system built in that allows you to have a robot with some components running on one computer, in this case a Raspberry Pi. The controller is another node in the ROS system in this case. You can then have another one on a PC, and you can kind of spread it out as much as you need to. If anybody's seen the massive, literally 100-foot tall Gundam they have in Japan, it's like it's in a gantry and it can kind of walk forward and look around, and it's got smoke that comes from places. It runs on ROS, and God knows how many computers they've got dotted around the body of that thing. But yeah, you can, as long as they're networked, they can talk together. So one of the things I alluded to before was the kind of the use of the Unity games engine. So I'm actually starting to develop a virtual reality control system for this so that you can get the 3D environment direct from the robot and use the controllers to move the arms around. It's going to be a tricky thing, but it's something I've wanted since day one, and, you know, go big or go home. Thankfully, Unity already has plugins for ROS, which is really handy because I don't have to write them that way. But it means that you can then do stuff like use the Steam Deck. So when I saw this announced, I thought this is an ideal robotics controller. Oh,
we could all hear you.
Yeah. So for those not familiar, it's essentially a PC. It runs Linux. It has a bunch of useful joysticks, buttons all over the place. and I think an 8-inch screen or something like that. Also has a really good graphics card on board, surprisingly. Well, unsurprisingly, I guess. So you can actually run artificial intelligence stuff on here, and any data coming from the robot, you could use this for the computation for navigation. So yeah, as daft as it seems, I like having excuses to put games consoles through my company budget. So, and it's entirely reasonable. I think I've played one game on this as well. So it's not like I bought it to play games on it, but yeah. So that's me unloading a lot of stuff from my brain about Pi Wars and how I got to where I am today. But one of the next things is Hacky Racers. So those not familiar, Hacky Racers have been around for a while. It was started in the UK by me, Mark, and Rory, and a group of similar-minded nutjobs who basically wanted to get together, build small electric go-karts. So there's a budget of around 500 quid, which is kind of... there's a meerkat jumping at the window. You've got about 500 quid, but at the same time, anything related to safety doesn't come out of the budget because we're daft, but we're not stupid. Batteries and a few other things, because they're expensive and we don't want people to buy cheap ones that explode, also not included in various ways. So 500's kind of hit and miss, but it's a good thing to aim for, to get people to build stuff cheaply and to have a laugh with it, because we want to get as many people involved as possible. And quite frankly, when we stole the rules wholesale from the US's Power Wheels Racing for Adults racing series, they had a $500 limit. They'd been going 13 years, so they'd learned lots of mistakes. So we literally picked up 13 years worth of hard-earned rules and just kind of went with it, with their blessing. So yeah, these are typically the sorts of things people race. They're about 900 mil wide, no more than 1.5 meters or something like that. I'm the compere. I haven't built one, so I just literally talk while the races is happening, and other people do the hard work. With Pi Wars not happening this year, and with something that we'd been discussing for a long time, is what if we made these autonomous? Because they're not dangerous enough as it is. So yeah, the original plan was to start developing the prototypes to bring to EMF 2024. We then found out that Pi Wars were going to have a year off, so we thought, oh, let's steal that spot. So we got in touch with the organisers, who were kind of happy to help us out, give us pointers as to people to talk to about venues and things like that. And to kind of make it a lot easier than people having to build something like this to then turn into a robot, we've got 3 different scales of robots that you can build. So there's essentially the Pi Wars class, which we've called A4, because that's the size of the sheet of paper it should just about fit on. Probably like the lowest barrier to entry. And again, this is a Raspberry Pi with an off-the-shelf motor controller on a 20 quid remote control car. Incidentally, one of these chassis were also what I used for the original McFeagle Prime. I think I've probably already mentioned that. I have no concept of time. And yeah, so you know, this is the starting point for my entry. And the great thing about being the compere, but these being autonomous, is I can press go and then carry on talking. So yeah, this is kind of an example of the A4 class. Mark has gone up a scale. Can I lift this up? Yeah. Can I lift this up, or is it? Yeah. This is a Tamiya Grim Reaper, or based on one certainly, and this is the A2 class. So this is the slightly larger version. Funnily enough, there's the donkey car rule set for robotic cars covers robots of about this size. And then there's the Formula F1 tenth, which covers about this size. So we're again stealing someone else's rules, but kind of reusing them for our own purposes. But the idea is, you know, if you want something relatively easy, or if you've already got a Pi Wars robot, you can bring it along and race. If you want to go for something a bit bigger and a bit quicker, you can build something like this. And if you're completely mad, which I completely support if you are. I mean, I'm no one to talk to about being sane. I've got bits of paper to prove I'm not and everything. I'm not going to do that because I might clamp on the battery and I don't like fire. You can make one of those autonomous. So for the full-size Hacky racers, we're going to mandate that it has to have a pilot on board, for the simple fact that I dread to think what our insurance would be like if you didn't. So you've got to be sat there ready to take control. Quite frankly, if it's good enough for Tesla, it's good enough for us. There's another rule that I think SparkFun had in their autonomous racing thing was you have to do the race holding a half-full cup of coffee. For one thing, it proves that you're not doing anything because you have to be waving and holding a cup of coffee to prove you're not actually controlling anything. But also, if you've got coffee left at the end, you've got extra points because it must have been a really smooth ride. I love daft ideas like that, so we'll see if we can get that one in there as well. We're still kind of putting the rules together. It's the last weekend in July where we're aiming to be running this event. And yeah, we're still kind of putting the rules together because this is the first event we've run. And when people come to us, we're going to be able to go, oh, that's a good question. We've not thought of that. And just kind of make things, not make things up. We are going to collaboratively develop the rule sets with community support. We're not going to make it up as we go. So yeah, that's the idea. Now, it's very early days yet, but one of the things I also want to do is I've got two very similar chassis to this, and I'm going to be building them to be identical. And the idea is that if you've not got a robot to build, you can still come along and we'll help you kind of get code running on it so that you can get involved without having to have the know-how of actually developing a robot from scratch. So I'm imagining something along the lines of you'll have a simple way of seeing what data's coming from the sensors, so you know how close you are to a wall, and you'll be able to control the steering and throttle. So it'll be like take as many steps back as possible to get as many people involved as we can, because we know building stuff like this isn't trivial. It often takes an awful lot of either expense to buy these things through breaking them and having to replace them and things like that, which I've done more times than I admit. There's also the time of learning how to do it. So anything we can do just to kind of jumpstart someone's interest, to kind of give them something. Look, here's a thing, go race it. We want more people involved. I mean, that's why we're doing this. We're not even going to try and run it as a competition. We just want to get people to turn up and race and see who can go fastest. I hear stories from Robot Wars and BattleBots, and I see it all the time in like Hacky Racers pits, where if something goes wrong, everybody else helps. Like I hear stories from BattleBots where somebody completely destroyed their opposition, and they're literally giving them spare parts from their robot to help rebuild it in the pits afterwards. People just want to have fun. The who wins what at the end is a massive bonus, but yeah, it's all about helping people build cool stuff. From the fact my throat is feeling really dry and croaky, I've probably been talking for far too long. So yeah, if there's any, where's that one? There's my things. Ignore Patreon, I'm shutting that down. I forgot to remove that. But yeah, the top one, the top three, I'll just kind of hold my hand over that. But yeah, the github.com/NeaveEng is where everything's going to be published before too long. Twitter, which is probably the most useful one, isn't actually on there because I didn't plan that far ahead. That's where I publish stuff. Ask for my card afterwards. But yeah, if you've got any questions or anything like that, either ask now or forever hold your peace, or just ask me online.
Well, the spare car idea feels very much like Pyborg's Formula Pi, where everybody had the same chassis and just worked on their own code.
Oh yeah, pretty much. I mean, I mean, we're not claiming to be original on this. There's no point reinventing the wheel, despite the fact I've done that many times.
I think it's a great idea.
So yeah, it's yeah. We'll like say follow me on Hacky Racers on Twitter, or hackyracers.co.uk for more information about the events and things like that. Or just ask questions. So any questions?
A question about this robot.
Yep.
How do you control or chain these robots, these servos? Does it have a bus to going to servos, or every servo has separate?
Yeah. So for the sake of the microphone, I'll repeat the question just because yeah, I don't know how this all works. But the question was about controlling the servos and if they're controlled individually or if they're on a bus. These Dynamixels have some kind of serial. It's half duplex, which is kind of annoying, but there's this little USB device here, which is USB to TTL, I think they call it. It's called U2D2, which I just love on principle. But you have an SDK. You say, I want to send this command to the servo with this ID, and it sends it. There's also ways of sending commands to a group of servos or getting data back. So rather than having to poll each one individually, which can take some time, you can just say, right, all 16 servos, I want to set to these different positions. And they're all different positions you can set to. But it does that in one command rather than having to poll through them. So it's just a lot quicker. And yeah, the one great thing, incidentally, is that you can unplug this USB cable and plug it into a PC. So rather than having to do all of your development work on the Raspberry Pi through a remote desktop or whatever, you can just plug it into any old PC and just do it there, then send the code over, and it's the same SDK, so it just sorts itself out. So yeah, I can recommend them. But test them early, and if they start overheating, send them back immediately, because otherwise a couple of weeks before your event you need them for, you'll find out you've got an arm missing. But yeah. So yeah.
You said about using magnets in your housing how do you attach the magnets to the print so they get pulled out by their own kind of
Super glue.
super glue?
Yeah. So it's I think I added a 0.2 millimeter clearance on the print.
Yeah.
So if you put a dab of super glue in there and then kind of press them in, they just stick in.
Yeah.
There's another thing I actually did for the. You won't be able to see this again. The shoulder cog here actually has a bearing embedded in the 3D print. So it's designed to be embedded. And what you have to do is when you go into your slicer software, you can you press the slicing. This is how it works in Prusa anyway. I assume it's the same everywhere else. You press slice, and then you have a thing you can drag up and down to show the different layers as it's printing. Select the layer at which you want to stop the print. So the last one before it then covers over where the bearing is, in this case. You can then put a pause command in there. The printer physically pauses and waits for you to press the button. You drop the bearing in, press go, and yeah. The only problem is I've actually got 3 or 4 of those cogs that didn't print quite properly and now have bearings embedded in them. And I designed it strong enough that it's actually quite a pain to get them out. So I'm going to have to go at them with a hammer at some point on principle. But yeah, it's the first time I've done that, and it wasn't my idea. I took the idea from other people, but it works really well. You can do similar for changing color, incidentally, as well. So the Neave Engineering logo on here, I printed the upper deck of this and then put in a printer pause command, changed the filament, pressed print, and it printed the other color on top. It's a very cheap trick, but it works really, really well. Yeah. Anything else? Cool.
Your remote talking to your robot, is that using just Wi-Fi between 2 Pis, or you've got some other protocol?
It's using Wi-Fi via an access point,
Yeah.
which is a whole level of pain in itself. So the previous version of this that had the stereo Pi up top actually had 2 Wi-Fi adapters. So it was literally a mobile router. It was brilliant, just for the pun alone. So it kind of broadcast its own access point. you could connect to it and then tell it to connect to whatever Wi-Fi of the event you're at. Because it's a nightmare trying to get everything talking and then trying to find its own where the IP addresses have ended up, because some networks do and don't have DNS and all sorts of nonsense. But that worked an absolute treat. And incidentally, because the controller was talking directly to the robot, it reduced latency. So the video came back that little bit quicker. You know, the controls, you know, they all work that little bit quicker as well. So I need to get that reconfigured, but this one only currently has 2 USB ports, and they're sticking right out where the left arm usually smacks right into them. So I need to figure some hacking for that one. But yeah, it's yeah.
What are you running on the screen on the remote?
Right now, a web browser. So it's, if I'm going to be honest, it's so there's my wonderful beer guts. So these images were taken from my spanner recovery robot, which is a whole story in itself. I essentially lost the spanner underneath my workshop, and it's slap bang in the middle of the floor where I can't get under. So I thought, why don't I build a robot to go and rescue it? Because, yeah, it'll be a fun, quick little project I can do between Christmas and New Year's. I've already got all the parts. What is it now? Almost May. What was I talking about? Completely lost the track.
Taking photos.
Photos, thank you.
Get
Yeah,
stuff onto your screen.
yes, sorry. Yeah, so this is using something called StreamEye, which you can just pass it images and it sends them out over a HTTP stream. In this case,
Spanner recovery bot. You don't have the right spanner.
well, thankfully it's the 13 mil one I need to rescue, and this robot's far too small to need that one. But yeah, so this sends out the front and back cameras. Originally they were side by side, but I figured if you get stuck, you're going to need to see behind yourself, and that was just an easy win, really. So yeah, just getting that up on the screen so you can see what's going. And one of the switches here does forwards or backwards. So if I ended up needing to go in the other direction, rather than having to think, right, okay, so I'm going the other direction, I need to go backwards, but I need to go, no, press the switch. Robot does maths, problem goes away. And yeah, you just need to flip up and see the other camera. So yeah, it's all just firing it out over Wi-Fi. The plan for this was to have some kind of proper interface, you know, showing either the cameras or the map it's generating or something along those lines. And that's kind of what I'm slowly developing for that. There's also something called Foxglove Studio, which you can download a Docker container for and just run it. And it presents loads of really useful stuff from ROS in a web browser. So you can actually chop and change what modules are on there. You can show, if you're doing an outdoor rover, you can have an actual proper map with GPS overlaid on the top. You can actually send commands from it as well. So you can press a button to send a message over ROS. And lots of cool stuff like that. I have had it running on there. I've just never had a robot stable enough to actually configure it all properly. But yeah, it's if you can write it to show on a screen, it'll just appear. But yeah, incidentally though, as daft as the rescue robot is, the plate I've designed for the top that holds the Raspberry Pi and the sensors and everything. It was kind of an excuse to build the plate, because now I've basically got, apart from the battery which sits underneath, a thing that you can bolt onto a remote control car, and you've got a robot. So, you know, it's got motor controllers on there, it's got servo controls. So this one, obviously, it's skid steer, but there's absolutely nothing saying you couldn't use those servo outputs to go into a normal remote control car throttle or the steering and things like that. So it's an easy way of get these things, print these things, you've got a robot. You know, so it'll help me and hopefully help other people as well. So yeah, it's an excuse for me to play around building more robots, I'm not going to lie. But if it can help others, it's a bonus. big bonus. So, oh God, that's the Keegan hasn't stopped talking alarm. But yeah, so any other questions? Cool.
What will be your next project?
The luggage. I don't need encouraging. So, so there's a big cargo robot I've been trying to build on and off over the years, which started out as a way of getting stuff to and from the car to the campsite at EMF. It was a long way, and despite having a smart car at the time, it was amazing how much crap you could fit in it, and it was just like, just far enough away, it's like, I can't be bothered to do this. If I had a robot that could do this, and then if you've read Terry Pratchett's Discworld, there's the luggage, which is this incredibly malevolent, homicidal trunk, wooden trunk, that is magical and sprouts hundreds of tiny legs and will follow its owner everywhere, even into the afterworld. So even if you end up, killed by surprise, you'll at least wake up in the underworld with clean pants. And if you're between it and its owner, you will get eaten, and no one will know where you went. I went to Primark to buy 104 quid's worth of toddlers' shoes, because I actually built these wegs, they call them. They're kind of wheels, but they've got little shoe feet at the end. So I've got like, one of my friends started staying at my flat, and I said, okay, I'm just going to tell you now, if you start finding toddlers' shoes around, it's for a robot I was building. Please don't call the police. So yeah, I want to get that built. I did try and get a version built for EMF last year. The structure was there, but I was utterly broken at EMF. I think Mark can allude to that. And yeah, it never quite got working because it was a mess. So yeah, that's the next thing, is like this big cargo robot. Which you never know, I might get it working for Thursday. It is, it's going to be astonishingly silly. But my mother even made me a red cloak with gold stars on it to go with the Rincewind theme as well. I just need to get a red helmet with wizard with 3 Zs on the front of it. But yeah, so that's kind of the next big project, is something equally daft but big enough to run me over.
Sounds like the perfect autonomous Hacky racer.
Yeah, well, the one bit of that project I actually got working, which I was quite proud of, was I made a little controller for it, which clipped onto your belt. And it had a GPS receiver on board, a little screen and a battery. Had an GPS receiver antenna that sat on your shoulder, and it could talk to a base station to get incredibly accurate GPS measurements, to the point where I was getting 10 millimeters accuracy. So the idea was that if it had this level of accuracy and the big robot had the same, you could basically press and hold a button and it would follow you. So rather than having to faff around with computer vision and things like that, if it's accurate enough to know exactly where you've been stepping, then it's probably there's enough space for it to follow suit. And yeah, the controller for that is a Wii nunchuck, which is brilliant. You can still buy them. They just use I2C of all things. So you plug it into the bottom and it's got a remote on it for manual control as well. So the robot didn't work, but that remote is absolutely beautiful. And the GNSS base station is going to be at the Hacky Racers event as well. So if you want to use that level of accurate GPS, it'll be there and available. The current enclosure for it is literally a biscuit tin. Because on the way to EMF, I realized I didn't have anything to put it in, so went to a supermarket, bought a tin of biscuits, drilled a hole through the bottom, job done. Incidentally, the metal lid on it actually acts as a really nice ground plane for the GNSS antenna. So it was kind of thought out, but just still mad. Yes. Thank you.
Yes,
thank you. Yeah, thank you to the event organisers for having me as well. It's always good to come and have an excuse to come and meet more people who like silly stuff.